Welcome back, everybody, to part 2 of this section 2.2 for advanced topics. But if you're an algebra student, welcome anyway. It doesn't matter if you have a certain label or whatever. If you're just trying to learn about slope and types of slope, you're in the right place. So here we go. We have 4 different types that we're going to talk about today. The positive slope. Okay, I like this guy. He's real positive. All positive slopes go from lower left to upper right. Okay, lower left to upper right. Now, if it's a steep slope, it's going to look like this. Okay, this is still a positive slope. Okay, or it could be really shallow if it's a small slope. But it always moves from a lower left to an upper right position. Okay. Next thing, negative slope. So negative slope is just the opposite. Instead of going from lower left to upper right, it goes from upper left to lower right. So it looks something like this. Okay, so negative slopes will always go in this direction. Now, why is it important to know what negative slopes look like? Well, it's a way to check your answer. If you get done graphing and you know you're supposed to have a negative slope and it's looking like this guy on the left, then you know you messed up and you should take a second look at your work, okay? So that's why it's important to know that. Now, zero slope. Zero slope is a horizontal line, a flat slope. It's always going to be in the form of y equals a number. Okay, so zero slope looks something like this. This will have a y-intercept. It's got to cross the y-axis at some point, whether it's positive or negative. It has to have a y-intercept. Undefined slope, this is when you're dividing by 0 with your slope, and we have no y-intercept. It is a straight vertical line, but it does have a x-intercept. That's why it is in the form of x equals a number. Okay, positive slope, negative slope, make sure you check those. Those are going to be the values in slope-intercept form for your m, your slope value, and it's going to be always the coefficient of x. Okay, so parallel lines and perpendicular lines. Parallel lines, just a little bit about them. We know that these are lines that don't intersect. Lines that don't intersect or cross. That's the same thing, that don't intersect. Okay, that's one thing about them. The most important thing about them is they have the same slope. Okay, they have the same slope. For example, y equals negative 2 over 3x minus 2. Y equals negative 2 over 3x plus 50. You're thinking, whoa, hold on. These equations are drastically different. We have 50 and then we have negative 2. These definitely can't be parallel. It doesn't matter. The thing that's important is the slope. If they have the same slope, then they are parallel, okay? Now, perpendicular lines. These are lines that do cross in a specific way, that cross at a 90-degree angle. Okay, so they cross at 90 degrees. They form right angles when they cross. These have a very special slope. They have opposite reciprocal slopes. Okay, so, I forgot to draw, this is the best part. Parallel lines, they look like this. And I'm just going to copy and paste it. Copy. I think I got the T on there. Yes, I did. There. So those are parallel lines, and you may even see them with a little caret on them to show, or 2 carets even, to show that they're parallel. Okay, so perpendicular lines, opposite reciprocal slope. So first I'm going to draw a diagram. We're going to have something like that. We're going to have something like that, and they need to form 90 degrees. So they're going to form a 90-degree angle in there. Opposite reciprocal slopes. Let's talk about that. So let's use our same example, negative 2 over 3x. Let's make it plus 3 this time. Opposite reciprocal. So we're looking at this guy, and we need to make him the opposite reciprocal. What does opposite mean? Opposite means that we need to make it from positive to negative. So opposite means we go from positive to negative or negative to positive, okay? So right now this is negative, so we need to make it positive. You don't really have to make the plus sign, but I just wanted to show that. Now, reciprocal means that we're going to take whatever numbers, let's call it, I'm just going to use A and B. So if we have A over B, the reciprocal is going to be B over A. So we just flip the numerator and the denominator. So in this case, if we're doing the reciprocal of this slope right here, let me just go like this, I suppose. Okay. Different color? I think a different color, right? Maybe this like light blue color? No, let's go this light purple. Okay. So now we're going to do positive 3 over 2. Okay, again, opposite, we went from positive to negative, so instead of having it a negative slope, we're going to make it a positive slope. Instead of having 2 over 3, we're going to make it 3 over 2. Everything else we can keep the same, and honestly, the y-intercept doesn't even matter either. It doesn't have to have the y-intercept. For both of these, the y-intercept can be different. So let me write that down, I guess. Y-intercept can be different, and this is for both. If we're just interested in perpendicular lines and parallel lines, then we can have different y-intercepts, okay? So in this case, it doesn't really matter. We're just going to put, I don't know, plus 7, okay? So the important thing for a perpendicular line is that we have opposite reciprocal slopes. You can pause this if you need to take notes or whatever. Are 2y equals 3x minus 6 and 2x plus 3y equals negative 6 perpendicular? Well, like we showed before, the first thing we're going to want to do is we want to get it into slope-intercept form. This is the easiest form to see what the slope is. That's why it's called slope-intercept form. So your step 1 is going to be get into slope-intercept form. Slope-intercept form. That's going to be your first step. Okay, what does that mean? That means we solve for y. That's why it's important to be able to solve for any variable in an equation. Now, how do we solve for y in this first example? I suppose I just need to rewrite it, don't I? Oh well. 2y equals 3x minus 6. We're going to divide both sides by 2. And make sure you divide both terms by 2. So we get y equals, I like to just leave it as a fraction anytime it's a coefficient of x. Those 3 halves x minus 6 divided by 2 is 3. So there's my first equation, 1. And now I have to do it for the other 1, well, other 2, I guess. Whatever, you guys get what I mean. So now we have 2x plus 3y equals negative 6. First thing I'm going to do is I'm going to subtract 2x from both sides, get that over, get the y by itself. 3y equals, I'm going to put the negative 2x first, just out of consistency. Now I divide both sides by 3. I get y equals negative 2/3. I like to make it as a fraction. And then we have negative 6 divided by 3. That gives me negative 2. Okay, what do we notice? Well, we have different y-intercepts. We don't care. The y-intercept can be different, so we're good there. We don't need to worry about this negative 3 or this negative 2, okay? Now we are going to analyze their slopes because it wants to know if they're perpendicular. So we have a positive 3 over 2. We have a negative 2 over 3. Are they opposite reciprocals? Yes, they are. One is positive, one is negative. That's a check. So are they opposite? Question mark. Okay. And then are they reciprocal? Both need to apply. If only one is missing, then we don't check the boxes. In this case, we check this one, we check that one, and they are perpendicular. Okay, so that's how we do it. Opposite, reciprocal, check, check. The y-intercept doesn't matter. Find a parallel and perpendicular line to y equals negative 2/3 x minus 7. Okay. Now, the first thing we need to know, do we need to know about the slope? I almost gave it away. Do we need to find out about the y-intercept? No, we don't care. We don't care about the y-intercept. The only thing we're really interested in is the slope. So here's our slope. Okay. So what do we want for a parallel line? Let's do parallel in blue. A parallel line, we want the same slope. So we're going to say y equals negative 2 over 3x minus 7. We want the same slope. Now, we don't want minus 7 though, because that's the same line. So we just need to change the slope. The y-intercepts can be different. I'll make it just positive 3. We've been rolling with that. So parallel, this one is parallel because it has the same slope. Same slope. Okay. Let's go orange for the next one. We have y equals, now we want opposite reciprocal slope. Okay, this is our perpendicular one. What's the opposite reciprocal? Again, we need to make it from negative to positive. So we have positive 2 over 3 so far, but now we need to flip it so we get positive 3 over 2. X, we don't care about the y-intercept. Let's make it plus 3 again. It doesn't matter if it's the same as the other one. Do I need to extend this line a little bit? Is that bothering anybody? It's bothering me. Opposite reciprocal slope. And again, I think I used purple last time, so let's be consistent. Purple. So we have the opposite reciprocal slope. There we go, perpendicular. All right, last example, and then we're done with 2.2. From birth to age 7, a girl's height changed from 21 inches to 47 inches. What was the average growth rate per year? Okay, so we're kind of changing gears here. We're talking about rates at this point. So this is a good thing to know. So from birth to age 7, so birth is age 0. Okay, so we're talking about age 0. And then we have age equals 7. Okay, so these are going to be two different points. So we have age 0 and we have age 7. Notice how age is the x-axis. And then we have, what is this, height as the y-axis. So make sure you label that. So we have our age is going to be the, let me change this to purple. Style purple. So we know our x is going to be in this location right here, and then our y is going to be in the right location for the ordered pair. Okay. So age 0, okay, how tall? So it changed from 21 inches to 47 inches. So when they were 0, they were 21 inches. And then when they were 7, they were 47 inches. Okay? So what are we going to do? We're just going to plot these 2 points. So we have 0, 21, so right about here. And then we have 7, 47. Now I'm not talking about the airplane. 7, 4, 7. Okay? So our line looks something like this. So if it was a linear growth, which it's not for humans, but this is an oversimplification, that's what it looked like. So what do? Well, we need to first label our points. So we have x1, y1, x2, y2. It doesn't really matter which one you call x1, y1, x2, y2, as long as you're consistent with the 1s and 2s being together. Now to find our rate is the same thing as slope. So we are going to do y2 minus y1 over x2 minus x1. So let's go ahead and fill in those values. I should have used green instead. Let me change it. Style. This green color. Okay, there we go. Feel better. So now we have y2, which is 47, minus y1, which is 21, over x2, which is 7, x1, which is 0. What do we get? 47 minus 21, I think is 16. Is that right? 6? No, it's 26, I think. So we get 6, yeah, 26. 26 over 7. I don't think that can be reduced. If we wanted to put this in decimal form, we could. So we just get a calculator out, and we do 26 divided by 7. So we do 26 divided by 7, and that equals 3.7. Now what does that mean? 3.7, we need to put this in context. These units right here are inches. Inches are on the top. What's in the bottom? Years. So inches per year. So 3.7 inches per year, okay? And that's how you do a rate problem. Hopefully you found this helpful. Thank you so much for watching, and I'll see you next time on Wes Explains.